Hey guys, welcome to part 2 of our 1.5 notes. I wanted you to start with an activity. If you could, grab a piece of paper. You can use lined paper. Actually, might even work better because you need two lines here. And a straight edge. And you'll need some scissors. And see if you can draw this picture on your paper. Use your notebook paper lines to draw the two parallel lines. And then draw a transversal. If you remember from last time, this line that intersects two or more lines is called a transversal. And then put in the numbers of the angles. And if you need to pause the video to wait for me so you can get that done, do that now, pause it now, and then pick it up. All right, we need to, after you've got the picture drawn, you need to cut it across along this dotted line right here. Cut it straight across. And I just want you to see something. I want you to take these four angles right here, and I want you to bring them up to these four angles. And what do you notice about those? Hopefully you notice that they're exactly the same angles. Hopefully you notice that anytime I have an obtuse angle, it's going to be the same size. So 1 and 5 and 4 and 8 were all obtuse angles and they're all the same size. 6 and 2 and 3 and 7 were all acute angles and they were the same size. So you can see the congruency. You can see which ones are equal and which ones are not equal. So hopefully you can see that in that little diagram. All right, this is kind of a big slide. You can pause it, get it down if you need to. In this diagram, we talked about the special kinds of angles last time. And we know that in this diagram with this thing right here, these two symbols, these arrows, means that they're parallel lines. If two lines have arrows, that means they're going the exact same direction. In this diagram, there's either congruent angles or there's supplementary angles. Either angles that are the same, that will be exactly identical, or they're going to add up to 180 degrees. The congruent ones are listed right here. We talked about the corresponding angles. So you can see 1 and 5 are corresponding. 2 and 6 are also corresponding. 2 and 6 are small, the acute angles right there, 2 and 6. And 1 and 5 are obtuse angles. And then in alternate interior angles, you can see 3 and 6 are alternate interior. 4 and 5 are also alternate interior. They're also congruent. They're both obtuse. And then we have the alternating exterior angles. They're alternating sides and they're outside the lines. 2 and 7 are congruent. 1 and 8 are also congruent because they're alternate exterior and they're both obtuse. Your only pair of supplementary angles would be the angles that are called consecutive interior, that are 180 degrees. These two, it's an obtuse angle mixed with an acute angle. If you mix the two together, they can't be congruent because one's obtuse, more than 90, one's acute, less than 90, so they're not going to equal each other. They have to add up to 180. So I could say that even about 2 and 8. 2 is acute, 8 is obtuse. They're going to add up to 180. They're not called anything special. At least these two, 4 and 6, have a special name. They're called consecutive interior. So if one angle's acute and one's obtuse, they're going to add up to 180. If both are acute or if both are obtuse, they're going to be congruent. So you can pause it, copy that slide down. We're going to do a few examples from this slide. The rest of the notes are all just example problems. So let's take a look at this one. What can you say about the angles in this figure? What we could say is that we know angles 1 and angle 2 are supplementary. That means they're going to add up to 180 degrees. That we can tell. That's called a linear pair. So you could even write that down. Linear pair. These two angles right here are going to add up to 180. They're basically a pair of angles that make a line because they're adjacent to each other. We could say that angles 1 and 3 are going to be congruent. I'm going to use the congruent symbol. 1 and 3 are congruent because they have a special name. They're called corresponding. They're called corresponding angles 1 and 3. 2 and 3 are going to be supplementary. Those two have a special name. They're called consecutive. I'm going to abbreviate consecutive interior angles. So consecutive interior angles would be 2 and 3. These two together make 180 degrees. 180, not 186. All right, next example is it just says solve for x and y. So these two together are a linear pair. We just talked about 1 and 2 being a linear pair adding up to 180 right here. So, sorry about that. Okay, so 67 plus something has to add up to 180. So you're basically just going to do 180 minus 67. You're going to get a 3 and a 1 and a 1. So you're going to get 113 degrees for x. And then x and y are alternating interior. X is congruent to y, so y has to equal 113 degrees. 113 for y. So x and y are both 113. This bottom one down here, you might notice that this is obtuse. It's more than 90 degrees. This one's obtuse. It's more than 90 degrees. Therefore, they must equal. 5y must equal 115. Those two angles have to be the same amount. They do have a special name, alternating exterior. If you divide by 5, you're going to get y equals 23. 23, not degrees. We're just talking about solving for y there. Now in this one, this 89 would be congruent to this one. Those two would be congruent. These two would add up to 180. That means that 89 plus 5x minus 24 is also going to add up to 180. So 5x minus 24 plus 89 has to equal 180 degrees. So this is an easy one to solve. You just combine your like terms. 5x, you're going to get a 75 here. Positive 75 equals 180. No, sorry, 65. Quick math there is better. 65 would be way better. So we're going to subtract 65. You're going to end up with 5x equals 115, and we just found out what happens when you divide by 5. You're going to get x equals 23. So those are some examples. You can pause it and copy those down. First experience with a proof here today. So I'm going to get to show you a little bit about what a proof is. A proof is when we have a given statement and we're trying to prove something. So right now they're giving us the statement and they're giving us this diagram, and they're asking us to prove that these two are parallel to each other. So they're telling us that angle 1 and angle 2 are supplementary. So that this number 2 and this number 1 are going to add up to 180 degrees. So they want us to prove that M and N are actually parallel lines. We always start with our given statement. So I'm going to take the given statement, which is right down here at the bottom, and it might not fit exactly. Let me make it a little smaller so it will fit. Angle 1 and angle 2 are supplementary to each other. Of course, now my angle symbols are all off. Go ahead and fix that for you guys. There. Angle 1 and angle 2 are supplementary, and that is our given statement. Now, what does supplementary mean to each other, or what are some of the things that we can say about this? We could actually look at this picture, and we could see that 1 and 3 are a linear pair. 1 and 3 are a linear pair. Let me make that a little smaller so it fits. 1 and 3 are a linear pair, and that's going to be the linear, the definition of a linear pair is that two angles that are adjacent and they make a line, they're called a linear pair. Now, if these two angles are a linear pair, then we can definitely say that we know they're supplementary. The definition of a linear pair is that they are a pair of angles that make a line. The fact that they do make a line means they have to add up to 180 degrees. So that means that they have to be supplementary. That's our linear pair postulate. Is that since they're called a linear pair, we know they have to be supplementary. Angles in a linear pair are supplementary angles. All right, so now if 1 is supplementary to 2, and 1 is also supplementary to 3. That means angle 1 makes angle 2 add up to 180 degrees. Angle 1 also makes angle 3 add up to 180 degrees. That means angle 2 and 3 had to be equal to each other. The only way that 1 could make 2 add up to 180 and 1 could make 3 also add up to 180 is if 2 and 3 were the same angle. We call that the congruent supplements theorem. Is that if they're supplementary to both angles, then they have to be equal to each other, or congruent. And then the last step is that we can prove they're parallel. We can prove it because if 2 and 3 are congruent to each other, that means these are called corresponding angles. Corresponding angle converse tells us that if they're called corresponding angles, then the lines have to be parallel. So that's just a brief proof there for you. Kind of a little tougher one than the next one I'm going to show you in a minute, so that next one will be a little bit easier. But here's 2 more quick examples for you. What is the converse of the following statement? We haven't really talked about converse yet, so we're not going to do this one, so you don't have to write it down. We'll get to converses in the next chapter. What value would make the lines parallel? That we could do. These two right here we know add up to 180 degrees. So we're going to add 2x and 3x and get 5x. So we're going to get 5x, and 4 and negative 9 is going to make a negative 5, and that has to add up to 180. So we'll add 5 to both sides, we get 185. Divide by 5 on both sides, you get 3. Let's see, 15, 35, 37. So what value for x? We would put in a 37. That would make them add up to 180, and the lines would be parallel. So again, you can pause it anytime you need to. The last slide is one last little proof that I wanted to show you. A little bit easier. It's just a quick parallels proof. It says given that 1 and 2 are congruent. 1 and 2 are congruent. So that's our given statement. And that's given to us. Now they put here 1 and 3 are congruent, and we just learned about angles 1 and 3. We know that 1 and 3 are congruent because they're called vertical angles. And we proved it in class, so we can call it a theorem. Because we proved it in class, you can call that a theorem, the vertical angle theorem. Now, if 1 is congruent to 2, and 1 is also congruent to 3, that means 2 and 3 have to also be congruent. We call that the transitive property from Algebra 1. You may or may not remember that. Transitive property. So that's what that's called. And then the 2 lines are parallel because of corresponding angles. Corresponding angles are congruent. 2 and 3 are in the same exact position. They're both in the lower right side. If they're both in the lower right side, we call them corresponding to each other because they're in the same position. Remember, we had corresponding, we had alternate interior. 1 and 2 are actually alternate exterior because they're alternating and they're on the outsides. And then we had the consecutive interior that added up to 180. But the corresponding angles are ones you're going to see the most often. So you really got to get down the fact that 2 and 3 are in the same exact position, both in the lower right side, so they're called corresponding angles. All right, we'll see you guys tomorrow.